Good evening. Welcome to this Meetup event. Please take your seats. My name is Julian. I'm the moderator of tonight's event, and today we have not only one, not two, but three speakers actually with us. So we have with us Bogdan on the left-hand side here with me. Then we have Kashif, somewhere already here, and Mary also. So 3 talks. Each talk will be about 25 to 30 minutes. We will also have time for questions after each of the talks. And then after the 3 talks, we still have some time in this location here for mixing and mingling at the bar. And this is probably everything I need to tell before I talk too much. Let me briefly mention that this meetup event is co-hosted by AI Camp and DeepSet. So thanks to our 2 co-hosts, I would say at this point. And then without further ado, we can get this started. So the first speaker is Bogdan, and Bogdan is talking about retrieval-augmented generative pipelines in connection with Notion. Please give a warm welcome to Bogdan.
Yeah, good evening, everyone. I'm happy to be able to speak to you today about retrieval augmentation in combination with Notion. A quick introduction about myself. My name is Bogdan. I was a machine learning engineer at DeepSet, and yeah, I was one of the maintainers of our open source framework Haystack, which is one of the tools that I will present here tonight. Yeah, but let's quickly dive into the topic. First word of the title is Notion. Some of you might not know what Notion is. So basically, Notion is a collaborative tool that helps you with a lot of different tasks. So you can use it for task management, for note taking, for knowledge sharing, to document some internal stuff and also for goal tracking. So basically summarized, Notion allows you to store and share all kind of different information. And with information growing and growing, it might be hard to find relevant information. Like this is how a typical Notion page looks like. So this is some example page, and these pages are organized in basically different blocks that can be of different types, like normal text blocks, but also tables, you can have images. And one of these blocks can also be sub-pages. And this is where things get complicated because you can embed pages into pages into pages, and then it might get difficult to find the relevant information. And this is where retrieval-augmented search comes into play. So I guess all of us have heard of large language models like GPT-4, but also open source models. I think the newest release was this Mistral model. And yeah, we all know that these large language models are capable of generating coherent text and that they're really amazing in it. But they have one big problem. They only can see info, they can only produce information that was fed to them during training time. So I don't know, let's say we would train a large language model today with all the information available on the web. It wouldn't know what is happening next week, so we can't ask it questions about next week. And yeah, this is where retrieval-augmented generation comes into play. So this is basically a technique combining retrieval and generation. And yeah, this basically enhances the generating capabilities of these large language models by feeding them some external knowledge. And here is where Haystack, our open source framework, is very useful. So to build a retrieval-augmented search application, you basically need three main components. One of them is a database, a document store that basically consists of all the information that you want to know stuff about. Then you need a retriever. This is the retrieval part of this RAG acronym. This basically allows you to, out of this database, your huge collection of text, to retrieve a minimal subset of relevant documents. And these relevant documents are then fed into the large language model to generate a coherent answer. And a typical RAG pipeline in Haystack would look like this. You would basically have a query as the input, like a natural language question. This question is then passed on towards a retriever. Here we have the embedding retriever as an example. So we embed the documents basically into a vector space to be able to have semantic search capabilities. But yeah, this could be also exchanged with some keyword-based retrieval like BM25. And this embedding retriever basically produces a set of relevant documents that might answer the query. And the query and the retrieved documents are then sent together to our prompt node. The prompt node is basically what powers these large language models. And this prompt node then generates our answer. And now the biggest question is, how do we add our Notion pages to our document stores if we want to use them as our knowledge base? So as I said, Notion pages can be embedded recursively, and this might make things very complex. If you, like, let's say you want to extract your whole Notion workspace, it's quite hard. And this is where this Notion exporter integration comes into play. This is some custom component that I wrote that does all this complex stuff for you. So you just need to pass your Notion API key and the IDs of the pages you want to extract, and it does it automatically for you. And this Notion exporter component can also be integrated into Haystack's indexing pipelines. So this makes things easier. And this is basically an example of how you would then integrate your Notion pages. So you would first need to install this Notion Haystack package. And here is an example. We use Weaviate as a document store, which is a vector database. And the indexing pipeline is then just as easy as adding our exporter, the Notion exporter. Here we specify also that we want to export all the child pages. So we really recursively go through the whole Notion workspace. And this exporter is then connected to our document store so that all the pages end up in our Weaviate database. So this is then an example of the pipeline that I showed before of this RAG pipeline in YAML format. So in Haystack, when we want to serialize pipelines, we use this YAML format, and this comes in handy for production applications, where you basically want to deploy your application in Docker environments, for example. And here, basically on the left-hand side, we define all the components that we are using. So, for example, for the retriever, we're using a sentence transformers model, and for the prompt node, we are using a GPT-4 model. And then the pipeline definition is basically as simple as this. So we just say, the retriever gets as input the query, and the prompt node gets as input the output of the retriever. And like this, that's everything we need to know to define our pipelines. I was just talking about deploying applications into production, and this is where Haystack's REST API comes into play. And here I basically show a Docker file of how to integrate this Notion exporter that I was just talking about into Haystack's official REST API image. So Haystack basically provides this handy pre-built Docker image that you can just run, and then you basically already have a Haystack REST API running as a backend. And what we do here is just installing this Notion exporter in there. And to build an application together with Haystack, we would also need to define our database. And this is where our Docker Compose file comes into play. So basically, we here define two services. The first service is the Haystack API that I was just talking about. They're basically telling it, hey, build this custom Docker file that I just showed. We are mounting our pipeline definition in there. This is this YAML configuration that I showed before. And then the second service is basically our V8 database that needs to be running as well to be able to use it in an end-to-end application. And now we don't only want to have like a REST API running somewhere, but we also want to have a nice user interface so that users can directly interact with our Haystack search application. And this is where Streamlit comes in handy, because it allows you to build quickly nice graphical user interfaces for machine learning applications. And this basically is first a helper function that we are using in our Streamlit user interface to make queries to our Haystack REST API. So we can see here is our URL. We have our Haystack API service with the query endpoint, and we are basically sending a post request to our backend service, and formatting it in such a way that we can further work with this. And as you can see also in the code, we are retrieving cited documents. So at the end, I will show you a quick demo, and they can see how we can make use of citations in large language models, because this is like one big problem that many users have with these, that they don't know if they can trust the generated output, and that's where users might want to check citations. And here we are basically making use of this function that I just showed, and formatting it in such a way that we can then show it in our Streamlit application. So basically, we are retrieving the answer string, we are adding our cited documents to the answer string, and then printing it on the screen with this success bar. So and now that we have basically written our Streamlit UI, the last step is to integrate Streamlit into our Docker application. So for this, we first have this small Docker file where we basically install our user interface package and the Streamlit dependency, and then expose it into the 8501 port that we will now have a look at. And last but not least, we need to add this code snippet into our Docker Compose file, so that our Docker Compose file in the end consists of 3 services. So we have one, the V8 database, which basically stores all the content for us. We have the Haystack backend, which interacts with the V8 document store and does all the handling with the large language model. And then we have our UI service, which basically presents our results in a nice way. So let's do some demo. So I created this small demo about integrating Notion into RAG pipelines. And the knowledge source for this is a page that DeepSet shares with potential candidates for their jobs. So it contains information about how DeepSet works, what are the benefits and stuff like that. And let's see this in action. So the first question that we can ask here is, what's DeepSet's mission? Let's see what the large language model will produce out of that question. So here we see DeepSet's mission is to empower developers to make natural language processing a part of every application in every enterprise. And we see we also have a source given. And if we check the source, we can see here, mission, we empower developers to make NLP part of every application in every enterprise. So that's nice. And as a potential candidate, maybe I like this mission, but I have a follow-up question. I don't know, maybe I like to work from home and not go to the office. So I asked the model if I can work remotely at DeepSet. And here we get the answer that DeepSet is a remote-first company, and it allows its employees to work within the European time zones, basically. And we also get the information that DeepSet provides a budget of 800 euros to furnish your own home office. And again, we get 2 different sources now for creating our answer. So here we have an FAQ page, and probably this is where the information comes from this, what is your approach to remote work at DeepSet? And here we have a whole section about remote work at DeepSet. Okay, nice. I can work remotely at DeepSet. And now maybe I want to know if there are also any in-person meetings, because I like also to meet my colleagues in person from time to time. And let's see what the model will return here. And we see that DeepSet organizes in-person meetings through its rebase events, which occur every few months. And we all again have 2 different sources given. The first one is again our FAQ page that we have seen. And here we basically have this question, are there opportunities to meet colleagues in person with the information given by the model. And then there's also this page about internal events. And yeah, I hope that in this talk you have learned what retrieval-augmented search is, how to set up a RAG pipeline in Haystack, how to integrate Notion as a knowledge base for your RAG application, and last but not least, how to build an end-to-end RAG application using Haystack's REST API and Streamlit. Thank you.
Thank you, Bogdan. And now we have time for questions here in the audience, but also online. And while I come to you with the microphone, maybe Bogdan can answer the first question that we got from the people attending online. How can we replace the OpenAI model that you showed, I think, that you used, with some other open source models? I see that.
Yeah, replacing the GPT-4 model is very easy. Basically, you just need to change the YAML definition. In here, we basically provide the model name, and you can just set the model that you want to use, and any model on the Hugging Face Transformers Hub should be supported as a prompt node in Haystack.
So maybe you can speak up and I don't need to come to you with a microphone?
So the question is, does it work with tabular data and whether it keeps the context of the conversation?
Okay, so the question is, can we do this also with tabular data and can we have conversations, right?
Can it keep the context of the
Yeah, can it keep the context of the conversation?
So I haven't tried it out with tabular data, but I guess this is very model dependent and requires some prompt engineering probably, like how you send the tables to the large language model. And what was the second question?
Context and conversation.
Yes. So Haystack has these components called agents, which also allow you to store the conversation history of your conversation with the model, basically. So that should be possible, yes.
There's a question about pre-processing a bit. So whether the data was chunked, the Notion data, maybe you can say something about that.
So I didn't do any pre-processing to the Notion pages because the example that I used, the pages were already quite small. But pre-processing shouldn't be a problem. You can just add after the exporter node here a preprocessor node that would basically take the exported Notion pages and then split them into smaller chunks.
Okay, in the very back.
Does it answer every question? Or if not, if it gives say, an unsatisfactory answer, can we tell that and provide boilerplate? Thanks a lot, reach out support.
Okay, so the question was, does the model always give an answer, or can it also say, I don't know the answer, can you specify some boilerplate answer in case the model doesn't know?
So this depends highly on the prompt that you're using. So in this example, you can see here, I was using this question answering with references prompt. And in this prompt, we basically specify the model to only produce information that is inside the provided documents. And if the answer cannot be if the question cannot be answered by the provided documents, then the model should say this question cannot be answered by the provided information. So.
Yeah, just a follow-up on the last one. Do you have a threshold for the similarity within the retrieval, or you just always pick the most similar ones?
Sorry, I didn't get the first part.
I mean, when you do retrieval, do you have a threshold on the similarity?
So how it's implemented in this simple pipeline is that we just take the top 5 documents here and pass it on to the large language model. But yeah, you could, in theory, also say, okay, if a document isn't too relevant for our question, or if we can't find documents that are relevant for our question, then we don't need to yeah, invoke the large language model.
And the row in front of you, yeah, next to you. Yeah, that's you.
Yeah, my first question is if there's some images or let's say pie charts or graphs in the pages, will the model read from that? And also another thing, what happens if you run the model again and like, let's say 4 or 5 times, does it give the wrong answer? And the question that asks, like, let's say there's some information, test that in life, like just as anything that is not in the machine pages, I'm just curious.
So there were 3 questions. The first one was about multimodality, right? Not whether it can only work also with tables, but now images and charts.
So this Notion exporter component that I presented really only yeah, extracts the text out of the Notion pages, and to images it produces some links so that you can retrieve them. But yeah, these images are not sent to the large language model. And what was the second question?
Yeah, the second one was like, let's say if you run some question multiple times.
So will there be hallucinations, or will it be always the same output? Will it be longer answers if you run multiple times?
So the wording might change a bit, but yeah, the general content of the answer shouldn't change that much because we're always using the same prompt with the same documents and the same information. And yeah, the last question was,
let's say if there's something not in the machine, can you just test that live right now?
yeah, I can test that. So
Where does Santa Claus live?
Hmm?
Where does Santa Claus live?
Where does Santa Claus live? Okay, let's see. I mean, maybe we have the information in Notion, I don't know.
yeah, unfortunately, this information is not present. So yeah, the model says answering is not possible given the available information.
All right, I think this is a nice question to answer this part of the presentation. Bogdan will be around, so if you have further questions, you can also ask after the presentations. And now we're also already getting ready for the second presentation with Kashif. Thanks again to Bogdan.
The adapter or Julia?
No.
Okay.
So while Kashif is setting up this presentation, yeah, I can give you a brief introduction already of the topic. So this will be about reinforcement learning.
Is that better?
Yes.
Yeah. All right. Thank you so much. I'm Kashif, and I'll talk about RLHF via this new method called direct policy optimization. All right. And feel free to ask questions. I guess you all know LLMs are extremely good and useful, and they have lots of practical use cases. But in practice, they also have a lot of problems. Some of them you saw from the last talk in keeping information up to date, giving consistent answers, which is not random. And also another problem is the problem of generating appropriate responses when interacting with humans. So the problem of putting them in production is that one needs some kind of guardrails to make sure that they're not doing something damaging. And this area of machine learning, or this area, is called alignment, right? And the pioneering methods used for aligning LLMs, which remember are just generative models trained on maximizing the likelihood of the next token given some prompt, is to use reinforcement learning with human preferences. And the pioneering method to do that, I guess, was the Instruct GPT paper from 2022. Right? And the idea was to use a model of human preference as a reward function, and then slowly nudge the probabilities of the LLMs to so that it kind of maximizes the expectation with respect to this reward, so that it generates higher reward, it samples higher reward tokens, and doesn't sample low reward tokens. And in this way, you kind of are better aligned with human preference. So let me just quickly show you, give you an overview of Instruct GPT. The pipeline is given in this schematic, and it's 3 distinct stages. The first stage is you kind of start with your general pre-trained LLM trained on like trillions of words, and then what we do is essentially supervise fine-tuning, which is essentially how you train the initial model as well. But this time you do this supervised fine-tuning on your data, on your specific data. So for example, if you have say instruction following data, you want to fine-tune this model on a subset of this data, so that the model is better in some sense at following instructions from the start before you do anything. That's step 1. Step 2 is when the model kind of generates answers from instructions, we ask human evaluators for feedback on, say, which of the 2 outputs the model generated human prefers, and we catalog this. After we've done cataloging this, we train a so-called reward model on this kind of preference data. So that's step 2. The final step is to use reinforcement learning to tune the language model to the preferred preferences via this trained reward model that came from step 2. So essentially a kind of complex pipeline, but I'm going to go through in some detail of the steps involved. I guess step 1 is relatively clear. So we'll skip to step 2, which is the training of the reward model. Unless there's some questions. So essentially, as I said, for the reward model, you need a data set of this catalog preferences. And this data set typically looks like a prompt and then 2 possible answers. which have been selected by humans as say the winner and the loser. And if you collect this kind of tuple, then this complete data set I denote with D. Right? So the reward model, as I said, is just basically an LLM where you chop off its head and then you add a linear layer that outputs some score. And then your preference model, the model of say which output you prefer is given by this simple kind of goodness function here. It's essentially you're predicting the goodness of with respect to some reward of the winning prompt, the winning completion, as well as the losing completion, and then you want kind of a logistic function which gives a binary probability to the winner, and it gives more probability to the winner and less to the loser. And this is typically called the Bradley-Terry model. Right. So once you have a concept of a loss, you can just train a reward model. So essentially, you cook up a reward model with parameters phi, and then your loss is eventually you sampling many of these prompts with the winning prompt and the losing prompt, and sticking it into the log cross entropy loss given by this Bradley-Terry model. Yes.
How many samples do you usually need?
You'll need these tuples as well for the third stage. So typically, with my experiments, I've selected maybe 20% of the data set for the reward model. But as you train, you're of course logging everything, and you can also have a validation data set, and you can also then check the accuracy of your reward model with respect to that as well, and do early stopping or. Yes, please.
Would you mind explaining the Bradley-Terry model?
It's very simple. It's it's just the sigmoid of the rewards. So you want one reward to be high. If this is your loss, then you want the reward for the winning one to be high, and the reward for the losing one to be low.
And you want that
the thing will return a probability between so it will return a probability between 0 and 1, and there's a threshold, and then everything above say 50, you want it to be, you want to select that, and otherwise you select the other one. Right. So with this loss, it will push the reward for the winning one to be higher if you minimize this, and it will push the reward for the losing one to be lower. Where remember, this reward model is now a language model with parameters 5.
For the example, I think you were showing there could be like more than 2 examples, right? A, B, C, D, in that case, how does that work? If you go back to the previous slide, you were showing like there are like A, B, C, D, like 4 examples, right? Like,
Or example.
How does that work here? Because the example now is
Right. So whenever you have preferences, then from this preference, you can still create this tuple, right? So you'll create a tuple where your D will be bigger than C, and then another tuple where D will be bigger than A, and another where D will be bigger than B, and so forth. So from this BCD kind of ranking, you can generate many tuples of this form. No. It's just pre-processing from the way these preferences are cataloged. R is some number, some score. Remember, you chop off the head of the LLM and just output some number, some logit score, and you want such a loss with the sigmoid, log category, log sigmoid, where you give high score then to the winning and low score to the loser. So it's just you chop off the head and add a linear, which outputs just one number. Yes.
And is the set of answers but predetermined specified beforehand, or the answers appear in different questions, or new queries to produce new users and winners that
so this is fixed, I guess. Did I? Yes.
Can you repeat the question always for one?
Yeah.
Repeat the question.
I'm sorry. Did I? You were asking about is the answers
predetermined and are every query to be may see new answer and
so in this situation the data set is fixed so it was fixed when we were doing step 2.
they appear in different questions, in different queries.
Yeah, you can. I think that's not a problem. So you can repeat things as well. Is that?
I mean, if, for example, for why I is the loser, maybe in another question, it is the winner.
Yes, of course. Depends then on the prompt. Yeah. Of course. Maybe there's an example of that. Yeah. So it depends, of course, on the X. Like which programming language is the best, and then the Y, W, and L can.
That is, in every query we see new data, there can't be any learning. That we should see them in
Every query if we see new data. I don't know. Okay, so that's a reward model done, I think. Let's move on to the RL, so which is the third part. Essentially the idea here is to nudge the LLM's weights or distribution. Remember, LLM is just learning the distribution of the next tokens via its weights. The weights here are denoted by theta. You want to nudge those weights so that given a prompt X, right, it gives a higher reward it generates things that give a higher reward more often, and it generates things that give low reward less often. So that's essentially the first part of this loss. This thing, right? So with respect to, you want to maximize this thing with respect to the parameters. We remember that now the reward model is frozen. So the only thing you can change are the thetas. So that's the kind of the first thing. So the first term essentially moves the model parameters to generate preferred responses, or responses that give a high reward. And also you don't want the model to kind of go off the rails too much or start to exploit the reward model. And so in order to kind of constrain it some way or regularize it, you essentially have this KL divergence term with the parameter beta. And this KL divergence term kind of penalizes the weights or the resulting distribution if it strays too far away from the original distribution of the model. Right? So in this way, things are kind of it still needs to somehow generate good answers, but still stay in the realm of normal language models. So here's a diagram from a recent paper that kind of depicts this production training workflow for reinforcement learning. And the only takeaway I want you to take away from this is that it's quite a complex pipeline. It's potentially unstable, and it's tricky to get things right, especially if you do things at scale. So the question is, can we do something simpler? And the DPO method I want to talk about is a simple alternative to this kind of complex method. And so the big idea of DPO is that if we can parameterize our reward model appropriately, then we can extract the optimal model from it without any additional training. So essentially, we can skip this complex machinery of reinforcement learning by just fitting the LLM with the reward with the loss and just the preference data that we have. So essentially, the DPO, given our preference data, we can cook up a maximum likelihood loss with respect to just the LLMs, and then in theory, because of the way we've cooked up the loss, the model should maximize the same loss, the same objective that we had in the RL setting. Let me show you that. So this is the RL objective that you know. Remember, there's two components. We want the reward. There's the reward model and the KL divergence term. And the reward model can be any function here, right? And it turns out you can rewrite this term in a closed form with respect to the most optimal, the optimal reward function that maximizes this thing. And it's essentially such a term here. And the thing about this term is that essentially it's a function of your reference model, the model that you want to stay close to, and the reward function, and this Z term. Now the Z term is an untractable partitioning function. Essentially, it's the sum of all completions, all possible completions, given the prompt. And this is the Z is kind of untractable, and you can't compute it. But we're going to stick with it and hopefully deal with it in a second. But essentially, all I've done here is some algebra and just rearranged and found the most optimal, language model. So again, a bit more algebra. We can rearrange that term to write a term in terms of the reward function here. So all I've done is just rearrange the last formula with respect to some model pi here. So in the last one, this was pi star, but it can be anything. So I just rewrote it this way. So now the reward model is essentially the intuition here is that this is a reward model that a policy is optimal for. Is just the ratio of the reference policy and the optimal policy. Here by policy, I mean the language model. And this ratio is positive if the policy likes the response more than the reference policy, and vice versa. So this thing is negative if the pi doesn't like the response with respect to the reference, and this is positive if it likes it. But we still have our problematic Z term. Okay, so now the big takeaway here is that we can essentially train our language model such that the reward function it is optimal for agrees with human preferences via this Bradley-Terry model. Another way of saying this is just that we can stick that formula that we had for our reward model into the Bradley-Terry loss. So remember, this was our kind of reward function with the Z term, right? And we just stick it into the loss for the Bradley-Terry term here. And remember, the loss for the Bradley-Terry was just the the reward for the winning completion minus the reward for the losing completion. And so that's these two terms. But now the nice thing is that this Z term cancels out. So we end up with this loss here, which doesn't have the problematic Z term, and it's just a very simple log likelihoods of these ratios, where these ratios, remember, are the probabilities of the tokens that the winning and the losing completions give you, given the prompt X, with respect to the reference model. Yes. Right. So then there's the sigmoid here. So if this one is negative, then the other one, I think it works out. Then there's the sigma term here, and then you take the log sigmoid of this as your loss. And this is essentially the reward model loss that you had when you train the reward model.
Would it also be possible to just scale this to a larger scale, avoiding negative numbers standalone?
Yeah, I think so. So the beta somehow controls that as well. The beta hyperparameter controls that aspect of it as well. Log sigma. Yeah. So the upshot of this is that given a so I'm just about to finish. I think given a reference model and our model that we want to train, we can just stick it. We can just use this log to just train it in a kind of supervised fashion, where we have our tuple of prompts, winning and losing completions, and essentially just train it without the machinery of reinforcement learning. And the optimal thing, the optimal thing here will be R star. And remember, R star was so if I go back, so R star was the optimal policy with respect to the reinforcement learning objective that we had previously. So in theory, at least, if you minimize this, you should get the optimal R star, which satisfies the RL objective. So in the Hugging Face TRL library, it's relatively simple to implement this now. Remember, the data set needs to have a certain structure, and the structure is this a dictionary where you have prompts, your x's, array of x's, and then you have your winning and your losing completions. Given this structure, you can create a training data set that will sample the appropriate tuples randomly or whatever. So once you have that, then in TRL, there's a DPO trainer, which you can then take in a model as well as a reference model and this data set, and then you can call train on it, and it will train it with respect to that loss that I showed you. Ideally, the model has to be big, and now there's two copies of it, the model and the reference model, where the reference model, of course, is frozen, but still there's two copies of it, and this might constrain some situations. I mean, this might be limiting in some situations. So as LLMs get bigger, nice, cost-efficient, and time-efficient method is to use LoRa, which the idea is relatively simple. You freeze the weights of your LLM, and then you just learn a delta. So you learn the delta over these weights. So only these things are learned, and these deltas are not the full matrix, but a low-rank decomposition matrix, essentially a long skinny and a small long matrix, so that when these two matrices are multiplied together, you still get the large output, and then you can add this delta to your output across the layers. And this way, this thing here has a small number of weights, and so by training using these adapters, you can train your large language models relatively easily on smaller or medium-sized GPUs, because it uses a lot less memory. And so the big idea, and the way to do it, of course, is to use in Hugging Face, use the PEF library. The PEF library for any model that you have. You can convert it into a LoRa model via a LoRa config, where you specify the rank, how much, the size of this deltas, and then you can then you have this LoRa model, which you then do the training on, and then at the end you can call this merge and unload, which will add those deltas back to the weights and save the model as if it was the original model. So the nice thing now with the PEF library is that it works really nicely with the TRL library, so you can train, do the reinforcement learning objective with LoRa adapters, where the reference model is the original model. So there's no need to, say, load the model twice. The original model is the reference model, and the model that you're training or aligning is the one with the LoRa weights. And this way, you're able to train DPO on much bigger language models. Okay, so I'll finish now. Just to summarize, I hope you're familiar with with this simpler way of aligning LLMs via DPO, and where it comes from. It's essentially the Bradley-Terry model with just some algebraic manipulation. Typically with RLHF, the main problem is that of evaluation, and how good it's working is really up to the evaluation framework rather than the metrics that you get when you are doing this training. So it's relatively important to make sure you have a nice evaluation pipeline in place as you're doing RLHF. Also, I mean, this is somewhat of a simplistic model, and this has no sampling in it, which is kind of the hallmark of our reinforcement learning models. And so there's other works in the pipeline which take inspiration from offline reinforcement learning to also align language models as well. And also there's a bunch of these papers where hopefully someone maybe here will contribute to the library to also add. Okay, so if you're interested in this line of work, do let me know, and I will stop here. Thank you.
So it's time for questions again, and there's already a first question online. It's about the PowerPoint slides, because people are interested whether you
Yeah. So everything that was underlined is a link. So once you get the PDF, you can.
Okay, and maybe we also upload the recording, so we can share a link to the slides and also there. Awesome. Other questions from the audience in the very back, please, very loud. Yes.
How did you start this DPO compared to DPO
To which method?
Yeah, I mean,
Maybe you can repeat the question first. And then...
how efficient? In which sense? Why? Yeah, mostly because I mean I showed you why do we want to use DPO instead of PPO? Well, I mean I guess I wanted to say that with this slide, right? So this is how typically you do the PPO side of reinforcement learning, where you also then need to store samples and all this business. Whereas with DPO, as I said, it's much simpler. Loss. There's only a model, and it's a LoRa adapter, and it's just much easier to get started, I guess. And the paper, of course, if you read the paper, it has much more validation about on comparisons with PPO and so forth.
More questions? Okay, let's start here.
So you did mention that the model was trained with a fixed data type, but in theory, could the probability of the winner loser be re-evaluated over time? But if you're scanning through online, and then things online are filled up by independent writers, and then some information can be either irrelevant or outdated over time. So in theory, and the winner loser track will be updated.
Can you repeat it again for the online people?
No, ask him to repeat it. No. Yeah, so he asked if the data can be, if the model can kind of bootstrap itself from the data as you train further and further. And I suppose this is essentially what these offline reinforcement learning methods are doing. Yeah, so the DPO itself deals with static data, and there's no sampling afterwards. In, I believe, RSO, I think you sample then, and then you filter out, or you filter out the data, and you throw away data that you know is has low reward. It's not going to help you, and generate more data that has reward, and then test. You generate more data from the model, and you test it with a reward model. But all those things need a reward model then, or some preference model, a ranking model.
All right, there was another question there. Yes.
Would you shed some light on what some pointers in terms of framework on how do we define guidelines for the because none of the papers actually start about.
Yeah, I can repeat the question. Was easy enough for me. So it was about annotation guidelines, and for all these approaches, there's some human annotation effort involved. Can you shed some light on what kind of guidelines we can give to these people?
So I guess crowdsourcing, people use crowdsourcing, which is kind of a shady part of this whole operation. It's maybe Shoaib knows more. Yeah, it's really bad, I think.
I mean, it's in the news.
Yeah. So you have kind of sweatshops, I guess, that
I mean, the scale is another thing I was more concerned around. Some
instructions.
Yeah, how do we define that?
Right. So I believe there's actually a workshop about it, and then the OpenAI people also gave a talk about it. They prefer that instead of scoring things, people just rank. Ranking is easier, and then they can deal with the generating this data from those ranked answers.
All right, and for time reasons, I will say thanks again to Kashif.
No worries. Thank you. Did I go over time? I'm sorry. I'm sorry.
Mute. Okay,
Yes, and then also
okay.
the camera.
Camera, oh, you want the camera on?
For the audience.
Oh, audience online,
Mhm.
okay.
And then just share the screen.
Okay. Share screen. All right, I probably should share the whole screen because I need, well,
And it's
actually,
just desktop up there.
desktop, okay, all right. But although, I'm trying to think, this
Let me
way,
see
would it make sense then? Because, okay, I need to, okay,
Looks good
okay.
to me.
Okay, I just need to try to find my, I got too many tabs in here. Okay, here we go. Okay, I'll just do that and then, yeah, and then slideshow. Yeah, yeah, got it right. Yeah, okay.
Then the stage
Thank
is
you.
yours.
Thank you. Thank you, Julian. Okay, thank you everyone for coming and staying, to hear me talk. And pardon me, because I just actually came from Amsterdam. Okay, so I'm a developer advocate, so I travel everywhere, and I was actually in two different conferences and different presentation last week in Amsterdam. Yesterday, I was at AI Camp in Amsterdam too. So I'm coming down with a cold, and so it's pardon me. If you can't hear me too well, just let me know. Okay, so let me do this one thing. I was kind of thinking I like to take a picture first, like a selfie with audience, because then I can show my boss. Here. Sometimes we get this. Okay, thank you. All right, so again, my talk is a more higher level, although too is that I want to introduce this vector database, vector search that my company has. Maybe before I go into it too, may I ask you how many of you, let's say already, are you all working deeply in machine learning, in AI? Yeah, I guess most of you, right? And how many of you are kind of working with vector database? I'm curious to, so a few, not many. So which one, or have you heard of data stacks? We have a vector database. Anybody heard of data stacks? Okay, Apache Cassandra. Has anybody worked with it? Okay, so that's what our company is. We are the commercial arm of Apache Cassandra. And then about 3-4 months ago, we added in vector data type. And then now we're kind of claiming we are, I should say, right? But we are kind of fully capable to support generative AI. So that's the talk about, it's more of an introductory. So bear with me a little bit, because I think maybe being a meetup format, I was assuming that not everybody has come in here with the same background. So I'm gonna touch on some basic materials too before I get into vector DB and vector search. So yeah, just bear with me. So thank you. All right, so okay, first of all, let me go into here. Oh, by the way, too, if you stayed, right? So I have some t-shirts, but I have to admit that because I came all the way from Chicago and I have to go to 3 different AI camp meetups. So there's no way I can carry all the t-shirts and they only send me like limited here. So I can only bring limited t-shirts. So I have some like about maybe 20, 22, 3. So if you are interested in getting a t-shirt, I'm kind of thinking if we get 22 people, then we have evenly distributed, although I have only like 5 extra large, 7 large, and 7 medium, and 3 small. So there's a chance you may not get the right size. However, if you want, let's say if we go over 22 registration, then I'm going to have to do a drawing too. So that's the thing. But yeah, but if you're interested, I have some t-shirts, and then if you're interested too, you still leave your email or something. I'll come back again and I'll bring more t-shirts to next time. Maybe I can send it over to Julian first, and then Julian can bring it here. Something. So okay. So this is the drawing, maybe like drawing for the raffle with the t-shirt. Yeah. Oh, thank you so much. Yeah, you just know what I want. Thank you. What a nice host. Thank you. Okay, so all right, I'll go ahead now. Okay, so let me see. I have this thing kind of, let me move it out of the way. Okay, so this is my agenda. Again, I'm just going to keep it short. It's the last talk of the day. So I'm going to give an introduction of myself first, and then a brief background of AI for those especially who may be new, coming in here from everywhere. And then also, then as you can see, then I'll step through all of the terms, GPTs, NLP, LLMs, all of these things, and then I'll get into vector database and vector search. And also, if there's time, because there may not be enough time, I'll be showing you how you can use, like we give out a free tier usage of Astra database, which is our managed Cassandra on the cloud. You can try out our vector search there for $25 credit per month. You don't need to give your credit card to. So I'll be sharing that information with you. And then after that, we'll just share some of the resources. So that's the plan for today. Okay, I want to make sure. Okay, all right, so who am I? Who's Mary? So again, I'm a developer advocate, but I have to say that working with AI is newer for me, I have to say, because I was actually I was a development engineer, but doing more Java development and open source for over 20 years or so. And then 5 years ago, I joined IBM as a Java developer advocate. And then I joined DataStax, where I am now, about a year or so ago. And I first started with helping with Apache Pulsar, which is an event streaming platform. So that's what I was advocating for until about 2.5 months ago, the company wants everybody to be working with generative AI. So that's why I'm talking about it now. But I think it's still good to kind of bring this good news to people and kind of introduce to you this capability too. So, okay, so this is just about me. I also am a community organizer, so I know how long it takes to run meetups. So thank you very much again to Julian. I run the Chicago Java Users Group, by the way. And then I'm also a Java champion, and I work, as you can see, mostly they are Java, but my interest is a lot into distributed systems. So that's my background. Okay, so I'll start then with a brief background of AI. I was kind of, when I first started to work on this like 2.5 months ago, I was thinking, let me try to understand AI a little bit more. But the thing is too, if you kind of look deeper, and what I've done too in my research was that like this can qualify as sort of an artificial intelligence in a sense, because it's a steam-powered pigeon was developed by this Greek philosopher called Archytas. And so essentially too, it's a steam powered. So the idea is that we want basically to be able to design something that we don't need to think, that we don't need to do. And that's the kind of ultimate goal. And just let the machine or robot something to do it for us. That's the goal. So now a bit of a near time history on this field. As you can see in the 20th century, there are a lot more activities going on, especially I think around World War II or after World War II that time. There are lots of kind of interest coming up. Alan Turing, basically 1950 was kind of talking about can machines think, right? So all of these things are kind of led to all the development that eventually has led to where we are today. I think it's really exciting. And if you kind of look through it too, I like to also kind of, with my background, a little bit too, right? And kind of ChatGPT so far, but I'm kind of thinking back to if let's say you have used MIT, they have AI lab, right? So they develop also actually it's GNU. GNU has this Emacs editor. Maybe some of you have used it, but there's like a doctor feature too. You can kind of like say ask the doctor. So that's a very primitive form of GPT or chat kind of chatbot type of thing. So that's kind of interesting, and that's all being developed at that time, 20th century. And then, of course, too, I'm highlighting 1997 was Deep Blue. I used to work for IBM, so that was also Deep Blue. That was also kind of AI kind of defeated like Gary Kasparov in chess too. So that was kind of an interesting thing. So okay, so kind of moving forward is basically we're talking about this is all about automation that we want to do. So this diagram, I think to all of you are very familiar. This kind of the diagram of AI, and it's really encompassing. Basically, you want to mimic intelligence of human beings and the behavior, the patterns of human beings and other living entities. And then machine learning is basically you want the computer to learn from the data without actually specifying rules. You just give it the data and have it learn, right? And then you go kind of more like kind of peeling an onion, right? Inside is basically dealing with deep learning, and that's something new, learning from neural networks, all of these things, all of these complicated things that Dr. Kashif was doing. So that's what kind of get into this layer. But I just want to set the stage in here. So now let's take a fascinating look at the GenAI era. So what is generative AI, right? Why is it becoming such a thing? So it is a disruptive field of AI. It's disruptive in a sense is that never before would be able to ask the computer question like the same way we are talking as human beings. Like if you kind of think about it, I've been a programmer for a long time. So you have to kind of conform to certain rules. It's essentially quite rigid too. If you don't follow that rule, nothing will work. So the thing is, right now you can just basically ask the robot, right? Ask the AI engine, ask it like the way you ask, and then you and I talk, and then it generates more things for you. The whole context it can create for you. So it's really revolutionary. So that's what we are kind of looking at too. So essentially, too, this technique is basically based on prompts, right? Without kind of prompts being kind of set up correctly, then you won't get the desired output. So that's why I think right now there are prompt engineers that is actually a career now. You want to make sure you're asking the right questions. So, and also with GenAI is that it tends to be dealing, okay, let's say before GenAI is basically predictive AI. Predictive AI is more with, you're looking at some data and then you're making predictions too. And if you kind of look into it too, predictive AI tends to be working with data that's more short-lived. So let's say you're making a business forecast or making a weather forecast. So once you make that forecast and once the time expired, then the data doesn't mean as much to you like that. Whereas for GenAI is that it can be more creative, more artistic. You can write a piece of music. You can write an essay. You can do, kind of write a blog post, right? As such too, I know I have ex-colleagues who are trying to kind of do a sales proposal entirely, having ChatGPT did it for her. So that type of stuff. Although we do need to be very careful with it because it doesn't mean, ChatGPT is always right too. So that's the thing. Okay, so now then let's take kind of in the history, right? Let's kind of go back. So since the new millennium, like 2000, so these are just highlight a couple of kind of the movement towards where we are now. So in, let's say like just 20 years ago, there was this feed-forward neural networks, right, in 2003. And then 2011 was Apple brings like AI and NLP assistance to the masses, and everybody's becoming more the thing because of Siri on your iPhone with your Apple phone too. And then 2013 is basically a group of Google researchers and they created Word2Vec. It's basically it's a technique for NLP too that uses neural network, right, to learn the word associations from a large set of text. And then in 2017, actually Google proposed another new like simple network architecture is called the transformer. So yeah, and then from there, now actually this one I just wanted to kind of talk a little bit too. I kind of thought too, this might be good to kind of talk about as introductory to kind of point is basically too, when I first got into talking about, AI too, I thought it could be confusing. But the thing is too, if you think about it too, there are actually kind of data scientists who are more theoretical in so to speak, right? A lot of theories, they are the subject matter expert too. But then at the same time, actually, it requires a lot of people to help, because interestingly too, I talked to another fellow speaker who's a data scientist, and that's what he told me. He said, the thing is, we don't know how to implement things. We still rely on the engineers to do the work for us, the DevOps people to kind of operationalize all of these pipelines and all of these things. So that's what he was saying, is that we would turn to these engineers and ask them what tools I should be using, like that. So essentially too, I just kind of wanted to bring these two kind of theoretical meeting with practical, and then that's what it is. So this is what the slide is. I probably shouldn't have put it in there, but anyway. Okay, so now let's kind of move forward. I talked about the transformer and everything, and then essentially too, we moved into like the GPT kind of time frame, right? And it's only 5 years ago. So what is generative pre-trained transformer? So as such, it takes like simple prompts in natural human language as input, and then it does what is called like pattern similarity search to kind of do searches. Because now we are not only dealing with scalar type of data, not single dimension. We're talking about multi-dimensional data that we want to capture it and study it and find out patterns and relationships too. And it's essentially too, GPT will answer questions for the prompts. And also, as such to produce contents like the blog article, it writes, an essay, and it composes some music, even like generate our program. When we're programmers, it helps too. If you kind of ask it, how do I write a linked list or something, it will just generate the code for you. That's kind of nice. So this is pretty transformative. So now then that revolution too started in 2018. That's when GPT came out. And essentially, Alec Radford published a paper, right, on generative GPT, and that was on OpenAI's website. And then from there to then 2019, GPT-2 language model came out too. And that was like, that one was based on like 9 mission documents, including text from URLs that shared in Reddit posts that had at least like 3 upvotes. So these are a bit back to some of history. And then as you can see, then 2022, kind of like post-COVID time, that's when Stability AI develops Stable Diffusion. And that's a deep learning text-to-image model that generates images based on text description. So it leads to, the DALL-E and also Midjourney, all of these diffusion-based image services to come out too. And then 2022 is basically when ChatGPT 3.5 was born, and it was revolutionary. Like within 5 days, right? The tool reached 1 million users too. So as you can see, this whole thing is like moving very fast, like wildfire. And then in 2023, as you can see, all of the big vendors are kind of catching up. Microsoft came out with integrating ChatGPT with Bing, and then Google has Bard, and also many other companies having their own ChatGPT version, right? And so basically, too, OpenAI also releases GPT-4 too. And that's one is better than ChatGPT 3.5. And then as such too, as we're speaking, there are new models that are coming out too. Yeah, so things are just happening real fast. So let's then take a look into NLP, right? Some of the things that are behind this, actually. Let me go back here. So what is NLP, right? Just kind of a quick note about it is interdisciplinary studies between like linguistics of computer science too. And the concern is process natural language data sets, right? It takes huge data sets, and it uses rule-based or probabilistic machine learning approaches, and it enables your computer to learn and then generate contents, and also not only to generate the context, but in including some of the context and the nuances of the language itself. And the ideally is to also draw insights from the documents too. So that's NLP. And then now, then there's LLMs. I don't need to talk too much now because both Bogdan and also Kashif, also kind of talk about LLMs, but essentially two LLMs, right? They are foundation model, and typically we don't do it ourselves because the training would take too much money, right? You need many GPUs and would take months, if not weeks, to process, and it performs NLP tasks and it generates and classifies text and answers questions based on prompts, just like humans too. So that's what LLMs are. And over here too, just some examples too of APIs that are popular that you can use to work with it, because sometimes you need to define templates or define any kind of interface like between all of these things. And for example, these are popular libraries like LangChain or Llama 2, and LangChain is JavaScript and Python, but there are also different ports too. And then Llama 2 is from Meta or from Facebook, right? And then there's Palm from Google, and that works with its Vertex AI API as well. And then Hugging Face too. I think most folks are familiar with these here. Just wanted to kind of point out. Now, as such, because I'm more of a Java person, so I look at it from more of a Java perspective, and just kind of curious, how many of you happens to be Java developers here? Anybody? No, no problem. I'm curious. One? Okay, one or two. Okay, no problem. But I just thought it's interesting because I run Java users group. Sometimes I try to kind of point out too. But these are just some of the Java libraries, because a lot of times people are saying that Java is not going to get caught up, but I think it will. And right now too, at our company, we have JLlama, which is like a port of Llama, the Llama library. So, and also too, there's a JVector too. So if you are interested in vector, basically this is like making use of the latest Java version. There's a project Panama that has kind of a special library that works with SIMD. It's a small instructions machine data sets. And so it kind of makes the vector data similarity searches really fast too. And it worked with DiskAnd too, the approximate nearest neighbor kind of algorithm. So something I just want to point out, because it was developed by our founder too. So, and it works with Java, but so far it's working primarily with Cassandra, I should say. So, and it makes your searches much faster. Let's say, Elasticsearch is using other forms of algorithms, whereas we're using the DiskAnd. So it's like much faster. Just thought I'd let you know. And then there's also LangChain. There's LangChain 4J, which is for Java, and Llama 2 Java 2 then is a port from Llama C. Okay, so now I'll get into vector database and vector search. So, I mean, looks like maybe most folks haven't worked with it yet, and this will be just a high-level introduction. What is a vector database? And so it's a purpose-built database that serves up vector data type, right, for complex machine learning purpose. And as such, as you know, we are now not, well, for machine learning, this type of purpose, right, ChatGPT, we're dealing with data that are multidimensional in nature, right? And so you can still use traditional database to do it, but it will take much longer too, because, as such, as you know, when we kind of dealing with machine learning, trying to do similarity searches, dealing with multi-dimensional data, we basically need like a new data type, and this is a vector data type that comes out. So essentially, what it is that like you can kind of take a look at the string that you process it, right? You tokenize all of your string, but you translate them into vector embeddings. These are vector embeddings are numerical representations of the different strings that you store. So if you kind of do a select, like in a database that's storing the vector data type, you would just see strings are kind of array of floating point numbers. And that's what it is, because it represents all of your data in its different forms. And so this way, when you're doing searches, it's actually much faster than if you have to do it in like the way, we do it dealing with string. If you translate them into numerical, it's much faster too. And of course, too, if you are kind of, you're more like familiar with math, actually I have to say too, I was a math major in college or university, math and computer. So I never actually got to use math until now, because you go out to work and it's like, okay, kind of maintaining, sustaining some code, you're looking at spaghetti code, nothing to do with your math. Finally, I'm actually working with linear algebra. I can apply to it now. So anyway, so this kind of similarity searches, in fact, too, you're making use of dot product, you're making use of Euclidean and also like cosine kind of techniques, right? So maybe some of you are familiar with it. So anyway, so that's what it is. And that's a vector database. And also there are different algorithms that you can use. And again, in our Cassandra database or our Estra, database too, we're using approximate nearest neighbor, ANN, this particular mechanism to do the matching. Okay, so now let's take a look at vector embeddings and what are they used for, right? So besides using it for searches like pattern matches, you basically can use it for clustering too, because you are looking for similarities of all of the text strings. If they can all be grouped by some similarity too. So you can use for that, or using that for recommendations, right? And you're looking at items that are sharing, like they are related text strings, right? You can kind of rely on all the embeddings to kind of determine to what it is, and then also anomaly detection as well. That's kind of good. And then also diversity measurement as well as classification too. So there's plenty of uses that you can think of using vector embeddings too in like generative AI type of applications, similarity searches. Now, again, the problem with traditional database in AI is that it's not able to handle the complex data type that's required in AI to handle, the multidimensional thing, the patterns, the relationships. So, and it should function like human memories too, but it's not so. So we need to provide the context for GenAI processing. So, but it's basically even the storage and querying too of these high dimensional data type is not efficient at all. So like I said, you can use it, but you're gonna be noticing very slow. Okay, so this is just another like diagram to kind of illustrate too. Earlier, Bogdan talked about RAG. So it's like over there too, like you can have in RAG apps, and essentially too, you can use, I guess like Bogdan uses Weaviate. So it's kind of a form of, it's a vector database as well. So you can kind of think of it like that. But again, I like to recommend DataStax because we're built on Cassandra as a NoSQL is the infrastructure is really strong too. So it's kind of proven. And so over here, as you can see, the vector database, you store all of the embeddings, and as you can see the flow like that, and is basically, it helps too. And also currently too, we have our engineering team also working on an open source project. Is leveraging event streaming. If you're familiar with events-driven streaming, it's basically giving real-time data. So for a RAG type of scenario, you're filling in some of the data that's missing, right, from your LLMs. You can actually stream those data in asynchronously, and then it will be much faster as well. We have this library called Langstream, and right now it's a 0.1 release, but we're working towards making it more production ready too. So, but just kind of mention to you, right now that streaming is using Kafka, but we can also support Pulsar, for example. So these are kind of proven like streaming platforms too, so. Okay. All right. So now, would you like to see the demo at all, or maybe just really quickly showing you, because you might be wondering, how can I use this vector database? So if we have some time, I'll quickly kind of just do that. Yeah. Okay. Let me go back. Oops. Actually, I'm like, I can't find. I got too many things. Okay. Okay. Here. All right. So basically, you can let me. Oops. Okay, so I'll give you this these cards too, where you can sign up for our our managed cloud platform. So astra.datastax.com is what you go to, and let me do that. So over here, as I mentioned too, you can sign up for it. And let's say if I'm brand new, you can sign up, and it doesn't require your credit card too. And so over here, you can quickly sign up in here, your first name, last name, and email. That's it. And then you can quickly sign up for it. But in my case, I already have an account, so I'll just say sign in. And I sign in with my Google account. Okay. Okay. Okay, so this is our managed Astra database, the console in here. So as you can see too over here, vector search, is now production ready. And basically, I can also quickly show you too. Let's say create database, and if you want to use Cassandra as is, you can still do it. Use the serverless database way. But otherwise, we're talking about vector database. So you can do vector database, and over here. Let's say right here, we can say Berlin, and then key space name. I'm going to do a quick demo too. So here I'm going to use Google Cloud in here. And US East in here, and then I can create the database. Oh yeah, I have reached a limit. So, okay, so yeah, I think I can use the same one from last night. So let me kind of show that to you. But okay, no big deal. It is true, even for employees too. I think we only are allowed to, I forgot to actually remove the other one. So, okay, yeah, and I forgot to remove the one from last night when I was in Amsterdam. So, okay, all right, so let me kind of go there. And so let's say, right, I already, over here, AI Cam AMS, that's the one I created last night. So over here too, if you want to work, I just want to quickly show you to how you can start working with this database that we just created. Let's say AI Cam AMS is the Amsterdam, same idea. So you can go to this CQL console. CQL is our Cassandra query language. It works kind of much like SQL, regular SQL too. So not too much different. So you can basically use this. Now, you can also use CLI, command line too, but right here, just for illustration purposes, it's a little faster, spinning up my shell in here, the CQL shell in here. So, okay, so actually here too, I already have that and have already created. So maybe I'll just, since for the sake of time too, I think I'm supposed to be ending. But over here too, just want to kind of quickly show it to you. And as you can see too, last night, what I did was with this example is I created a table that has ID column and description, and then the vector data column. And I specify only 5 dimensions. Now, as such, I mean, it's just for, hello world, so in reality, you have many dimensions, but of course it can handle it too, but there is also certain limit. But for just illustration purpose, I'm using 5 dimensions right here. So these are just the different columns to it. So, and then let me kind of quickly show you too. If you want to, let me do this one thing. Let me do this one thing. Actually, I have to do this first. Because there's also example too, I wanted to show you. Okay. Let me go back here. Okay, let's go back here. Let me see if it might work. Okay, here we go. Okay, so I can kind of like follow an example in here, but let me go in here. So this actually, for this particular one, you can go to our documentation, and our documentation has a section on Astra vector search. So over here, there are different examples. So the one that I was trying out is essentially this. There's one that says, how do you query vector data with CQL? So over here, if you follow that, it's basically, over here, I think it tells you how you can create an Astra serverless database, for example, and then you can kind of find out how you can do it too. But that's already done, but I just wanted to quickly kind of let you know how it was being done. And let's go back to this example. So you can just follow that and create table, if not exists. So it's pretty much like SQL kind of syntax too. And again, item vector, you specify as a vector type of floating, it's basically, you need to specify the type is floating point data type, and then 5 dimension of 5 embeddings in this case. So that's what I just did. But one thing I want to point out is that you can also create the index too. You probably also want to use like a storage attached index kind of technique that you want to specify to kind of work with vector data type. And that's specific for our Astra data type too, and it's very efficient too. And then over here too, then there are different things. And so maybe I won't kind of get into all the details, and then you can insert all of the data. And that's why I was able to show you all the data that came from last night. And then basically, if you want to do select, and this is again an example too, what you can try to do is select, certain columns, and then you can say similarity cosine, or you can use Euclidean, different, kind of similarity search type. And then you specify your criteria of the search criteria. And item vector, you have like 5 dimensions. I want to select the data that's closest to these 5 kind of, data, the numeric data in here. And then you want to also say ordered by, and ANN is the approximate nearest neighbor of this. And then you can kind of like see the results too. But anyway, and it looks like I may be running out of time, so I won't go into all the details, and I will be giving you this card. So I invite you to give that a try. It does, we don't bother you with, kind of sending you more junk too, so don't worry about it. But okay, so let me kind of go back to my thing over here. And then I'll just quickly say the benefits, right, of this whole Gen AI is that ask you shall receive, but make sure to ask wisely. And then also the work's being done for you, which is kind of nice and much faster. But there are without challenges too, like make sure you be aware of hallucinations. It may not be right. Don't trust in too much, and don't worry about our jobs going away, because ChatGPT is not trustable yet, I don't think, at this point. And also there are ethical concerns too, right? We're doing things that we don't even know what will come out. What if we generate images and have somebody kind of, you assemble somebody, the deep fake, for example, those kind of things, right? We have to be aware of, and there are no organizations out there to oversee us for doing the wrong thing. And then also the real-time, up-to-date data, that's always, I think it's very catchy. I think most of the things are still being done kind of batch-wise, so nothing like in real time. So like basically RAG pattern is a way to kind of fill in, to freshen up all of the data in LLMs. So, okay, and then with that is about coming to an end. So this slide deck can be accessed here if you're interested. If you're interested in it, and I don't know if folks wants to take a picture. And once you have it, then you have the other information too, but yeah, and then I also have these cards for the Astra database sign up too. Okay, and then over here is our vector search, our managed cloud platform. If you want to sign up, this is the bit.ly link and also the QR code. Again, you don't need to give credit card, and you can try it out. So yeah, okay. And then these are just some of the, the links that I have to show you the examples. And then also I have a weekly podcast too with my colleague too. We just interview people. If you're interested to join me, maybe we can have Julian to come and say something. Every week we have it released on Tuesday, but we do the recording on Monday. So yeah, we'll do that. Yeah. And also I have my Twitch stream. I normally would be doing like live coding, but with travel, I've stopped. But if you want to follow me there too. And then with that, just really quickly, right, we have Astra from DataStax, because DataStax sends me here. I have to say Astra DB, vector search, real-time AI. We have Cascada that does feature engineering, and also open source library Langstream. And with that, thank you very much. And thank you so much again. Yeah. Thank you. Thank you. Yeah. Okay.
All right, another time for questions. There's one online already.
Sure.
So you mentioned that one of the use cases of embedding is also outlier detection, or you said anomaly detection.
That's right.
And somebody was asking whether there will be also some approaches for that directly in the vector DBs, so especially mentioning DB-scan, so density-based, I think, spatial clustering.
Oh.
Yeah, so it's a very specific question. Maybe whether you think vector DBs will soon support anomaly detection.
Yeah, I would think it's probably eventually should be able to do that too. I think it's being new at this point. And there are so many vendors now coming out with different ideas. I wouldn't be surprised if maybe, yeah, going deeper into these anomaly detection, all of these, like doing, maybe even reducing hallucinations. And that's what our J-vector library is supposed to help out to reduce hallucinations, or at least that's what our founder is kind of telling us. So yeah, okay.
Questions here? Any questions from Mary? Maybe you can explain again how this raffle works. I didn't get it.
How does the raffle? You get the T-shirt. Oh yeah, that's right. The T-shirts too. How many? Actually, let me kind of take a look too to see. Yeah, if you don't have any more question, I can kind of go to the
distributed indexing you have.
Oh, distributed indexing.
They have like the distributed vector index. That's probably the most interesting. Like the
distributed indexing.
Yeah.
Okay.
So does that have like any?
Oh, the storage attached.
Have advantages, scaling advantages.
Oh, for storage attached indexing, right? In our
with vector, have you found use cases which are like it's just scaled? I don't know. I don't know if people using vector databases have run into scaling issues, but. Does that, have you your use cases like was that help?
Yeah, they're scaling. I believe that's what it should help to, and that's what it is. And also now I think with J-vector we have implemented like a formally release, and that's supposed to also help too. It's just much efficient and much more like essentially the good things. Yeah, but that's a very good question. Let me go find out more details for you. That storage attached indexing. Yeah, that's what we're recommending to use. And there's also a section to describe too in our documentation that you can also look into. Yeah, thanks for asking though. Yeah, but sounds like you're already very expert in using vector database.
No,
Yeah.
no, I just haven't seen distributed vector database.
Oh, okay. Yeah. Have you used much of vector database? No? Yeah. Okay. Yeah, okay. But thank you for asking. I like these challenging questions. Yeah, I can kind of take it back to and ask my engineering team, my founders too, the founder of the company. So yeah, okay, thank you.
All right, there are no more questions?
So yeah, let me.
Then thank
Then-
you
Yeah,
again.
thank you. Thank you. Thank you. Thank you. Thank you.